In this video, we're going to do some more examples solving trigonometric equations. So let's start with this example here. So we have 2 cosine theta plus 1 equals 0. So we want to solve for cosine of theta before we start. So we're going to subtract 1 on both sides and then divide by 2. So this is actually cosine theta equals negative 1/2. Okay, so then to solve, we would take cosine inverse on both sides, and we would see that theta should be cosine inverse of negative 1/2. And if you're using your calculator and you're in degree mode, then this will give you 120 degrees, which we know is 2 pi by 3. Okay, so that's one solution. Let's just draw our picture. Okay, so 120 degrees is this terminal side here. Okay, so if we want cosine to be equal to negative 1/2, we want the same x value. So that means our other solution is going to be down here, and it's in 0 to 2 pi, so we want to go counterclockwise. So it's going to be that. Now, 120 degrees is 60 degrees from 180. So that's our reference angle. So down here, we're going to have the same reference angle. So our second solution is going to be pi, or 180, plus 60. So that's 240 degrees, or 4 pi by 3. And those are going to be the only two solutions in the interval from 0 to 2 pi, because that's one full rotation. And these are the only 2 points with x-coordinate negative 1/2. So here the y-coordinate would be √3/2, and down here it would be negative √3/2. So those are the only 2 points on the circle where the x-coordinate is negative 1/2. So our solutions, in our interval is 2 pi by 3 and 4 pi by 3. Okay, let's try another one. So here our equation is in terms of cotan. So we're going to solve for cotan. So we have cotan theta is negative 1/√3. Now I want to switch to tangent. So cotan is 1/tan. Okay, so then if I take the reciprocal, or you could think about multiplying both sides by tan, and then multiplying both sides by negative √3, I'm going to have negative √3 is equal to tan theta. Okay, so this is the equation we want to solve. So my first step would be to find theta. So the reason I want to go to tan is so that I can use the inverse button on my calculator. So in degree mode, this is going to give you negative 60 degrees, which is in radians negative pi by 3. Okay, now there's 2 options here. So we're in the interval from 0 to 2 pi. So we could think about on a picture. Okay, so negative pi by 3 is down here. Okay, so we're going clockwise instead. Obviously, this is not in my interval. So what I would want to do, so we'd want a coterminal angle to negative pi by 3. So we just add 2 pi to that. So instead of going counterclockwise, instead of going clockwise, I'd want to go counterclockwise. Okay, so that's going to be this angle here, which is 5 pi by 3. Okay, so that one's the coterminal angle. So basically I'm just moving this angle to be in this interval. Okay, so I just want to find a coterminal one. There is another solution on here for where tan is equal to negative root 3. So tan is negative in quadrant 4 and also in quadrant 2. So the other one is going to be directly across. So it's going to be that angle there. So the reference angle here is pi by 3. So that's going to be this reference angle there. So this is actually going to be 2 pi by 3. So we have another solution. Oops. Is 2 pi by 3. That's in the interval. Okay, but another way you can find that, so you could actually just say, well, all solutions for tan are given by my original solution. Now you could use negative pi by 3 or 5 pi by 3. Doesn't matter. Plus multiples of pi, the period. Okay, so this is the period of tan. Okay, so you add multiples of the period. Now if k is minus 1, because this is almost out of my interval, so I want to go backwards. So if k is minus 1, 5 pi by 3 minus pi is 2 pi by 3. Okay, so that's another way to find that second solution. So all solutions in the interval from 0 to 2 pi are 2 pi by 3 and 5 pi by 3. Okay, let's try another one. Okay, so down here, I want to solve cosine theta equals negative 0.5. Okay, this is actually one we already did, so I'm going to go through it quickly. So theta would be cosine inverse of negative 0.5, which again in degree mode is 120 degrees, which is 2 pi over 3 radians. The other solution is in so this one is in quadrant 2. Okay, my other solution is in quadrant 3 because I need cosine to be negative, and it's 4 pi by 3 or 240 degrees. Maybe I will just draw the picture again just to make sure everyone's following. So 2 pi by 3 is up here. So to find our other angle, we want the same x value so that we have the same cosine value. So it's going to be like that, and the reference angle here is 60. So the reference angle down here is also 60. So that's why it's 240 degrees or 4 pi by 3. Okay, so now it wants a general formula. Okay, so all solutions are given by, so theta equals, so 2 pi by 3 plus multiples of the period. So that's going to give us all angles that are coterminal with 2 pi by 3. And then we also want all the angles that are coterminal to 4 pi by 3. Okay, so that would be our general form. Okay, so this is for k an integer. Okay, so any integer. And now 6 specific solutions. Okay, so obviously when k equals 0, so 2 pi by 3 and 4 pi by 3. Okay, now we could have k equals minus 1. So that's going to be, or let's do k equals 1 first. So I would add, so 2 pi, these are both over 3. So this is actually 6 pi over 3 if I make a common denominator. Okay, so 2 pi plus 6 pi is 8 pi over 3. Okay, 4 pi over 3 plus 6 pi over 3, that's going to be 10 pi over 3. So these ones are for k equals 1. Okay, maybe we want to do k equals minus 1. So that's going to be 2 pi by 3 minus 6 pi by 3. So that's minus 4 pi by 3. Or 4 pi by 3 minus 6 pi by 3. That's minus 2 pi by 3. So these values I found using k equals minus 1. Okay, so those are 6 different solutions. Obviously there's infinitely many because there's infinitely many choices for k. So down here, so this one is different because it's not a nice angle. So sine of theta being negative 0.2, so 0.2 is 1 over 5. This is not one of the ones that we've dealt with a lot. So we don't know, this is probably not a nice angle. So we could just find the theta is sine inverse of negative 0.2. And if I'm in radian mode, that gives me negative 2.01 radians. Now, if you're in degree mode, let's just check. Oops, I wasn't in degree mode. If you're in degree mode, so what it gives you is negative 11.537 degrees approximately. Okay, these are both rounded. So obviously not a nice degree. Okay, so we're not looking for exact answer here. So we can again draw our picture. Okay, so negative 0.2 radians or negative 11 degrees is going to be over here. Okay, so we're going that way. So if I want the same sine value, I'm going to have to look over here. Okay, and again, I also want a coterminal angle. So maybe let's do that first. So I'm going to use the radian. So 0.201, and then to find something coterminal, I want to add 2 pi to that. Okay, so that's going to be 2 pi minus 0.201, so that's going to be 6.08 approximate. Okay, so that's our first solution in radians. Okay, now the other one, so this is our 0.201 radians. So this angle here is also the reference angle, 0.201. So this one going from here to here is going to be pi plus 0.201. Other solution is pi plus 0.201, which is 3.343 approximate. Okay, now it wants on the interval, so those are actually going to be the only two. Okay, so solutions on the interval from 0 to 2 pi are 3.343 and 6.08 radians. Okay, if you wanted all solutions, you would just take each of these and add multiples of 2 pi. Okay, so that would be all of them, so without an interval. Okay, these are just the k equals 0 versions. Okay, so just one more example here. So we want to solve for sine theta here, but I have a quadratic form. So what I'm going to do is factor out. So I see a common factor of sine theta. So I can take out a sine theta. From the first one, I have 2 sine theta. From the second term, I have a plus 1. Okay, so these two things multiplied together equals 0 if one of them is 0. So that means sine theta is 0, or 2 sine theta plus 1 is 0. Okay, so that means we want to solve these two equations. So sine theta being 0, or sine theta being negative 1/2. Okay, now sine theta being 0 should be easy. Okay, so if you have to, I mean, you can do theta is sine inverse of 0. But it should be 0. Okay, so all solutions, there's only one here. So it's just theta equals 0 plus 2 pi times k. Okay, the second one, so sine theta equals negative 1/2. So I would do theta is sine inverse of negative 1/2, which, if you're in degree mode, is going to give you negative 30 degrees, which is negative pi by 6 radians. And I am going to draw a picture here. Okay, so when sine is 0, that's here. So the y value is 0. Oh, actually, sorry, I missed one. So I'm glad I drew the picture. So it's when sine is 0 at theta equals 0, but also at theta equals pi. So both of these points are where sine is 0. Okay, so the other solutions are theta equals pi, so all things that are coterminal with pi. Okay, so in the interval from 0 to 2 pi, over here we have 0 and pi. Okay, over here we're getting negative 30 degrees. Okay, so that's like that. So we want something coterminal with that. Okay, so I take negative pi by 6 and I add 2 pi. That's going to give me 11 pi by 6. Okay, and then my other one has the same sine value, so it's going to be the same y value, which I didn't do very well. Okay, but that's gonna, so this is gonna be the 30 degrees, or the pi by 6. So the other one is pi plus pi by 6, or 7 pi by 6. So all solutions in the interval 0 to 2 pi are 0, pi, 7 pi by 6, and 11 pi by 6. And if we wanted all the solutions that there were, so without an interval, then I'd want to add 2 pi times k to each of these, so all 4 of them. So those are some examples of solving trig equations.